So this is like second order homogeneous differential equation with constant coefficients. So we write the characteristic equation. The characteristic equation will be 2r squared plus 5r plus 2 equals 0, or you could use m, whatever you like. This one factors. You don't have to use the quadratic formula, but you can if you want. The quadratic formula will get you the right answer. But this one does factor. So we have a 2r and an r, and we have a plus 1 and a plus 2 here, equals 0. So that get us 4r plus r, 5r, and 2. So r is either minus half, because either the first one is 0, which give us 2r plus 1 equals 0, which gives us 2r equals minus 1, which leads to this. Or the second one is 0, which gives us r to be minus 2. And as you know, since these are real roots, the general solution, which is actually the complementary general, because this is a homogeneous differential equation, so the general solution will be C1b. Its exponential is raised to the r's, right? Minus 1/2 x plus C2e to the minus 2x. And now the initial conditions would enable us to find the constants C1 and C2. So let's invoke those. So if y of 0 equals pi, that just means when x equals 0, y is pi. So that means C1 plus C2 equals pi. And the first derivative means we have to differentiate this. So y prime is equal to minus 1/2 C1e to the minus 1/2 x minus 2 C2e to the minus 2x. And we know that y prime of 0 equals 1. So that means when x is 0, y prime is 1. So that gives us minus 1/2 C1 minus 2 C2 equals 1. And this is two equations and two unknowns. So to solve this, we can just multiply this equation by minus 2 or plus 2. So when we do that, this becomes 2c1 plus 2c2 equals 2 pi. And now we can add these two equations, where these two go away, and we get 3/2 c1 equals 2 pi plus 1. So that gives us the c1 to be 2/3 times 2 pi plus 1. And we can substitute back in the first equation to find C2. So C2 equals pi minus C1. So that's pi minus 4/3 pi, boiling the 2/3 into the 2 pi plus 1, minus 2/3. So C1 turns out to be minus 5 minus 2 over 3, which is the same thing as minus 1/3 into pi plus 2. So those are the constants, and we substitute them back into the solution to get y general to be C1, which is minus 1/3 pi plus 2 times, that's C1 times e to the minus half x plus C2. C2 turned out to be this was C2. So let's move this. So this was C2, wrote one by mistake, and this is here is minus 2x. So this is the second one, and the first one is minus 1/3 pi plus 2 times e. So the second one is e to the minus 2x, the first one e to the minus half x. And so this would be the general solution of the differential equation. Right here. Fairly straightforward. Those homogeneous equations are always done the same way. Characteristic equation, solving for the r's, plugging them into the exponentials if they're real, which in this case they are real. Substitute the boundary conditions to find the coefficients of the solutions, and then plug them back in, and that's your general solution.